Greetings to one and all. In the previous lecture, we have seen the following topics, that is types of data analytics, in which we had descriptive, diagnostic, prescriptive, and predictive. Then we saw the ML techniques, that is supervised and unsupervised machine learning algorithms, in which we also saw clustering and association. And here we have regression and classification. Okay. Now in today's lecture, what we are going to see is about reinforcement learning. Now in reinforcement learning, there is no label data again. There is no label. Labels are absent again. Now suppose this is a particular agent. He is put into an environment in which he needs to perform a particular task in order to survive in that environment. For example, his task may be whether it is an apple or not, he needs to decide, or his task may be to find an apple or whatever it may be. So in such cases, when an agent is subjected to an environment, there may be various sequences of decisions that he needs to take because he wants to attempt to search the destination or goal state. What is the destination or goal over here? To find the apple, or to say that, yes, this object is an apple. To reach the apple, that is the goal state, or to reach the destination. Now, the main approach that is followed here is trial and error technique. That is, when you're trying, you may either succeed or fail. Suppose you succeed, you will be rewarded. Suppose you fail, you will be punished. So when he goes through trial and error, there are only two possibilities. One is either reward and the other is punishment. If the agent receives a reward after executing an action X, suppose an action X is executed, and for this particular action, if it is allowed or if it is valid, then he will receive a reward. But suppose after performing this action X, which is not valid or invalid or not allowed, he will receive a punishment. The aim is to maximize the reward in the particular situation. In whichever environment you are subjected to, the aim is to maximize the reward and to survive or sustain yourself there and to gain experience, so that if there is any future new condition which arises, you will be able to handle it well. The output is not mentioned. What has to be done or what is the goal state, that is not mentioned. The main aim is to gain experience so that you can survive in that environment without having any negative effect. So in this way, the agent learns to live in the environment supported by the experience that it gains. So the main output of this is experience. And we know that the performance of multiple tasks T will increase the experience E. This is the main aim of reinforcement learning. So in our previous example, suppose apple was the case, then if it is correctly recognized, then you get the reward. Suppose this is an apple and you're saying it is not, then again it is a kind of punishment. That means you're not able to learn properly. So this is the main aim of reinforcement learning, in which you may be in a particular state or in a particular decision situation from which you may either get a reward, it may be a best action, and accordingly you can identify the algorithm. You have to develop the algorithm. The agent has to develop the algorithm and train itself. So another example is that the agent has to decide that which among these two is a duck. So this is a particular environment in which the agent has to observe and select an action policy or a sequence of actions that he can take. So in the environment, if this is a duck and he recognizes, he'll be rewarded. But if he recognizes this image, which is not a duck, then he will be punished. So he is saying in this particular situation, what is he saying? He is saying that the rabbit, which we know is a rabbit, is a duck. This is what he's saying. Now he may say this because he doesn't have the knowledge, he's learning. So he's saying that this is the duck. But now this is wrong. So he'll be punished. So there's a minimization in the score, or you can say negative marking is there, minus 50 points. So when he takes the action, he will either get rewarded or punished, or penalty also we can say. Now he will understand. Now what happened? He took a decision. The decision was that the right hand side image is the duck. But this is not a duck. That means this is wrong. So he will be punished. And if he is punished, negative marking, score reduces. So he'll understand that this particular choice that I made is wrong. So he'll understand what? This particular image is not a duck. So next time what he'll do? Another image which is similar to this, if he is given, he will say that it is not a duck because he has learned it now. Through experimenting, through trial and error, he is learning. That means now he will update his policy. He will update his learning steps and actions. And then he'll finally iterate again and again as per the requirement to get the optimal list of valid actions. Let us see certain examples and use cases of reinforcement learning. For example, this dog has been offered some food. So seeing the food or in the presence of food, this dog is witnessing salivation. His mouth is watering. Now suppose this is before eating. Now second case may be before food or at some point in time, a bell is being rung by his master. So he knows for now, at this point in time, he knows that till now I have not got food. So why should my mouth water? His mouth is not watering. So there is no particular action due to the stimulus. Third case is after ringing the bell, the food is served. Means what? He'll try to map the situation that if the bell is rung, after a few moments of wait, I will get the food. So next time what will happen that for the second time, when the bell rings, he will be under the impression that after a few moments I will get food. So from now on, his mouth is watering. So based on these two conditions, he has been trained that after the bell, you will get the food. Okay, so this is how he is learning in this particular situation or environment. Another example can be in a maze, the person needs to travel. So he may go this way, he'll go right side, he encounters the wall, he understands that this is not a valid path, he will return, he will go down. So in this way, he'll try to find an ideal path, all possible combinations, or until he reaches the goal state. Finally, he'll reach the reward. So you learn in this environment, which is nothing but a set of boundaries or a maze. Scenario 2, this child who doesn't have any knowledge who hasn't learned anything as of now, has to reach the candies. Now, if there is a particular object or a toy train in his pathway, he doesn't know. He'll bang into it or he'll dash it, he'll get hurt. Next time when he comes across this, he will try to avoid that particular path and he'll turn around and then go to the candies. So in this way, he will learn. Now, a famous example that is the AlphaGo game, in which this particular model was trained in order to learn about himself. So here he learned about himself. The chess had been played, and then he was able to defeat himself. So this is another example of AlphaGo. So another example of reinforcement learning in bank is that, or in any organization, especially a call center, what is the next best model has to be decided. So in the next best model, he will be able to identify that whether the offer to be provided is about a better offer or which one. For example, a particular set of offers is released. So maybe you have advertisement one, or let us say offers only, particular discount offers, or maybe some kind of customer attracting situations are created, or certain piece of services provided. So maybe you have offer one, offer two, and so on. Now, among these, you will try and test. You'll offer this particular offer one to customer one, to customer two, to customer three, and so on. And you will try to understand what is the majority of response that the customer is giving. Majority of all responses. So you'll understand that most of the customers maybe are attracted towards offer one. Similarly, for offer two, you will try it and you get to know that maybe only 20% of customers are attracted, whereas here 90% were attracted. So you will be able to suggest the best offer in such a case. So this is the way the best offer can be selected. Again, this is trial and error. Based on experience, we'll be able to understand which is the best offer. Another thing is allocating the resources to handle different cases of ER or any disease. To handle different cases, how to allocate the medical practices or the medical resources efficiently so that they are served accordingly can be a reinforcement case. For example, each patient may not respond the same way to the same medication, depending on the severity or his health condition, the condition of his organs, and so on. So accordingly, we can experiment and understand which is the best medication to which the patient responds well. Reducing excess stock with dynamic pricing means in stock market or maybe based on the behavior, we are trying to bargain. We are trying to give the customer a particular fair price such that we are also in a benefit as well as the customer also. So dynamically, we can decide that what should be the price. We should reduce it or increase it and so on. Now let us have a comparison between supervised, unsupervised, and reinforcement learning. Now there are a few parameters over here. Such as definition. Supervised learning is when we teach the machine using labeled data. Labeled data. Unsupervised is without any guidance. That means no labeled data, unlabeled data. And reinforcement, again, label is absent. So in terms of complexity or in terms of guidance being provided, in supervised, least guidance is there. Then we have unsupervised, little more guidance is provided. And then in reinforcement learning, no guidance. So in terms of severity, this is most complex, little complex, least complex. In terms of guidance, supervised is getting so much guidance, then little lesser for unsupervised and least for reinforcement. Next parameter is the type of problems. As I said, it can be a regression problem in which we have to decide the output, and the output will be a continuous value. For example, temperature. Temperature may be 28.5, or it may be 28.6 or 37, and so on. There are continuous infinite values. Classification is what? Finite number of categories, such as either the image can be a dog's image or a cat's image or a wolf's image. Then in unsupervised, we have seen association, for example, market basket analysis, in which the groups of items which are bought together frequently, frequent item sets are identified. Then we have clustering. In clustering, we are trying to identify similar characteristics between the objects and we are trying to group them together. Reinforcement, we are learning in the environment. We are trying to find out the solution wherein we can survive in the environment by increasing our reward. Next type of data, labels are provided. And we can easily classify whether the image is cat or dog. Here, label is absent, so we'll have to group them based on similarities as one type and another type. Now, the clustering algorithm will not be able to identify that which is the category. It will only be able to identify that, yes, this is a separate category, this is another category. Okay. It cannot classify, and it can classify but not tell which is that category. It can just tell that there's many other categories. And in reinforcement, again, there's no predefined data. We need to interpret based on the state, based on the action we perform, based on the reward or penalty we get, and survive in the environment. Next is in supervised, we have external supervision. That is, data set consists of input and output examples. No, not supervised in unsupervised, in which only input data is given. In no supervision or reinforcement, nothing is given. Based on reward and penalty as the guiding factor, we need to decide. Next is the aim. In supervised, we want to forecast the outcomes. Forecast the outcomes, such as which is the class, or what is the temperature, what is the weight. In unsupervised, we want to discover the underlying patterns, categories, differences, similarities. And in reinforcement, we want the learning series. We want to identify the set of ideal actions. Then the approach in supervised is perform the mapping between the input and output. Perform mapping based on the labeled input. Once you do the mapping, you can train based on that, you can develop the algorithm for the mapping, and then you can determine output for new input. In unsupervised, understand the patterns, discover the output based on unlabeled data, explore patterns and trends, and create classes. And in reinforcement, we need to follow the trial and error method. Then in supervised, there's a kind of feedback mechanism. Why can we say this? Because, as mentioned, in the testing data, we have input and output, say X and Y. We will test the model using the input. So this is our input. We are going to test on this, and whatever function, mapping function we have developed so far based on the training, as per the training, whatever function has been developed, we'll provide the input and generate something which is called as output, say Y dash. So for this particular input that we have considered, if the actual value of Y and the predicted value are same, then we can say that you are going on the right track. Feedback will be what in such a case? In such a case, feedback is positive. But if Y dash and Y are not equal, feedback will be that you're going on the wrong track or it is a negative outcome. So this is the feedback mechanism in supervised machine learning algorithms. Now, in unsupervised learning, there's no such feedback because he will just find the clusters or groups which are frequently bought. So there is no mechanism to say that whether what the clusters have been formed are the ones which will actually exist. That means we cannot determine the accuracy. For example, there may be certain hidden patterns or some bias which is not intentional, but unintentionally, since it was present in the data, such clusters have been formed. So there's no particular feedback mechanism here. Now, in reinforcement learning, we do have feedback, which is the trial and error thing. Trial and error, you may be either rewarded or punished. That is the feedback mechanism. The examples of algorithms are linear regression. Again, another kind of algorithm, logistic regression, support vector machine, k-means, random forest, which you'll see later on. In clustering, that is unsupervised, we have k-means, a priori for association, c-means, and so on. And in reinforcement, we have two types, that is Q-learning and SARSA, or state action reward, state action algorithm. Now let us see certain use cases, like what are the applications, and let us analyze them for which kind of algorithm will be suitable. Problem statement is study of a bank credit card data set and decide whether approval of loan is possible for such an applicant or not. So approve loan or reject loan. And you are given a data set which consists of the kinds of transaction. This is one example. Then this is another example. This is another example. So based on the behavior of the customer with the bank or with the withdrawing and depositing action, we can decide whether loan should be given or should not be given. Now here you can see we only have the inputs. Do we have any output or label? No. And we are trying to identify the clusters or groups or the categories with unlabeled data. Means what? It is a kind of supervised machine learning algorithm, and more specific, unsupervised, it is unsupervised machine learning since labels are absent, and it is trying to find the groups. One group or cluster is approval and one group is rejection. Next, in use case 2, it is a case where we want to study the mathematical equation for distance as a function of speed. We know that speed is equal to distance upon time. So speed can be calculated from distance. Okay, so speed is one of the features and distance is another feature or attribute. And for this particular speed, this is the distance. For this speed, this is the distance. That means we are given the input and the output pairs in the data set. So this is labeled data, and we are trying to predict a continuous output. So it is regression, that is supervised machine learning case. Next is to cluster. Now the problem statement itself involves clustering. That means it is a case of unsupervised machine learning. So cluster a set of movies as either good or average based on their social media likes or reach out. So here you have a total Facebook likes that are given, and here maybe you have actor 3, actor 1, and so on, other features. So based on this unlabeled data, you want to find the clusters or groups which may be popular or non-popular or average and so on. So this is another kind of unsupervised learning. Next, we have to perform market basket analysis, which we have already discussed, and we know that it is association That means it is unsupervised machine learning algorithm. Another example that an agent is in an environment like a maze, which you have already seen, and it has to find the way out. That is this one, say. So the goal is to reach outside the building or the room. And here we'll apply maybe Q learning algorithm, which comes under reinforcement learning. Okay, so this was it for this lecture. The remaining concepts we'll see in the next lecture. Thank you for giving me a patient listening.